Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you so much for joining this learning experience brought to you by Harness. My name is Cody, and welcome back to Tech Strong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again at a later time, or of course, if you'd like to share this with the rest of your team, we'll be sure to send you the on-demand recording via email here as soon as it becomes available. Should be within an hour or two of our program wrapping up. Now, if you'd like to get involved, there are a couple of ways to do so. The first option is to use that chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you're joining from. I'm seeing, honestly, just a lot of people from Texas right now in New York City. So everyone let us know from where in the world you're joining. Now, if you have specific questions, we do want you to send those into the Q&A tab on the right side of that chat section. And we will have time at the end of our program to address some Q&A. So be sure to send in those questions when you have them, and we'll do our best to answer as many as we can. Finally, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in your chats, your questions, and to, of course, fill out our post-webinar survey, which will be posted in the chat toward the end of our program today. So our topic is how to create an enterprise-grade GitOps experience. I'm joined today by Nick Lotz, developer advocate at Harness, and Ravi Lockman, Senior Manager of Product Management at Harness. So Nick and Ravi, thank you both so much for joining us today on Tech Strong Learning. Ravi, do you want to dive us right into the material today?
Yeah, appreciate it, Cody, and great to see everybody virtually. And yeah, please feel free to keep it interactive. So yeah, we'll be watching the Q&A and the questions in the chat. And so if we don't get to it right away, we'll definitely, we find a good interjection point, we'll get to it. So yeah, what are we going to be talking about today? So how to create an enterprise grade experience, with GitOps, or what does this even mean, right? So we're going to be in the next 40 minutes or so kind of walking through kind of some foundational GitOps items and then saying, hey, you know what is the next step? If you're using a GitOps paradigm, how does this look like in the enterprise? And so what are we talking about today? Well, exactly this. Like, well, what on earth is GitOps, and what does it mean to be enterprise grade? And then we'll be talking about some more fundamental pieces. Like, hey, regardless of whatever GitOps implementation or GitOps paradigm or engine that you use, these are like some of the basic fundamentals that any GitOps paradigm would enable. And then we're going to be looking at, well, now that we're looking at the foundational pieces, how do we reconcile that with actual real world need? Like, hey, if you're a financial institution or a bank or a manufacturing company, where do these architectures kind of meet the road, like where the rubber meets the road, and then how do you start reconciling some of these concerns into your architecture? And then also we're going to be talking about some common challenges not addressed by what standard GitOps are. So there's clearly like we have to implement this in a kind of environment that more than one person's in. How do we go about scaling that? And then also we're going to be demoing at the very end, like our persona that, hey, if you had to an end-to-end microservice, an end-to-end release cycle with a microservice, how do we do that in a GitOps type environment? And so welcome everybody. Excited to be here along with Nick. Really quickly, Nick, maybe for a quick intro from your side.
Yeah, definitely. Hello, everybody. My name's Nick Lotz. I'm based out of, today at least, sunny Nashville, Tennessee. I'm a developer advocate here at Harness, background in kind of the Linux ecosystem throughout my career, moving up the stack. I'll be sort of tag teaming with Ravi on some of these slides, and then exploring a bit of a demo near the end as well. So excited to be here.
Yeah, thanks, Nick. And I'm Ravi again. I'm a product manager here at Harness. My background is actually in distributed systems, and so in distributed Java for a while, and then kind of moved into platform engineering, and then kind of out of platform engineering into product management. So we're really excited to be talking about these topics today. And so let's talk about today's landscape. And so, Nick, why don't we just talk about really fundamentally, like you hear of CICD, like it's kind of the precursor or postcursor to GitOps. So why don't we just do some basic
yeah. So CICD has kind of been a combined acronym. Like over the past several years, you hear it used a lot together. Ultimately, though, they accomplish separate functions. So you're probably familiar with these terms: CI standing for continuous integration, CD standing for continuous delivery or deployment. If we were to kind of one phrase some of these terms, we might say that the CI part of DevOps and platform engineering processes tend to answer the question, is the code good? It's more of an adjective. We're checking for quality, performance, and frankly, whatever standards we choose to implement in our organization. So practically speaking, that means, automated builds, static analysis, dynamic analysis, unit and integration tests, vulnerability scanning, performance testing, code quality, ensuring that everything, that the code is free of merge conflicts, even at that fundamental level. And another term you tend to hear with it is the term shift left. The idea is when it comes to quality standards or just making sure our code works as expected, we want to perform all of those tasks early and often, not wait until we're close to deploying before we encounter problems. And then CD, on the other hand, even though, in a kind of cohesive end-to-end release management, it's used in conjunction with CI, CD is a little bit further downstream. It tends to more so answer the question, where does the code go? Now, often you hear the terms like continuous delivery or continuous deployment. Sometimes they're used interchangeably. If we want to be super technical, normally continuous delivery means we're automating all the process up toward maybe like auto deploy to a dev or staging environment. And then the release to prod, maybe someone has to press go on that. And then continuous deployment often means the full end to end. Once a commit lands on the main branch, it appears in production. You might have A/B testing and canary rollouts and chaos engineering that help, guard against, everything burning down at once on a bad release. But ultimately, there's a little bit of nuance between the two. It really, if we're going down to it, a phrase you often hear with it is make releases boring or make releases predictable. That is, have our process so standardized that we can deploy 100 times or 1,000 times a day, and it's a predictable, finessed experience.
Yeah, perfect. Yeah, excellent kind of explanation of those two kind of topics. And so kind of like taking that a step further, it's like, okay, like what exactly is GitOps? And GitOps is actually going to be focusing on your deployment portion of it, right? And so GitOps, was a term coined by Weaveworks, or the firm previously known as Weaveworks, in 2017, and they came up with really 4 basic pillars or 4 like pillars of GitOps, which is very true for today. And kind of going like left to right. Like the first one would be, the entire system is described declaratively. What does that mean? What you want in the end state, for example, hey, I want one replica, or hey, I have an application that needs to be exposed at this address. Like the state of the system, like if we can kind of extrapolate that, is described declaratively. Now, what ended up happening when GitOps was becoming popular was the rise of a very popular declarative state system. That system is Kubernetes, right? And so kind of with the rise, if you look back at 2017, like Kubernetes was coming into more popularity. This method of deployment was gaining traction. And so as declarative infrastructure was becoming more and more popular, thus the rise of GitOps. Given that, okay, what you want, your state is declared declaratively. The next piece would be, okay, the canonical state, or like exactly what you want, is in source control. In this, being GitOps, GIT, that portion of it is, the Git SCM, right? And so, modern approaches might not be, if you're not using Git, other approaches can apply here. But basically, hey, your configuration is stored in Git. So that's the second pillar. Kind of the third pillar there is, hey, you know what? If your changes are approved, right? I want to go from, I'm making a very Kubernetes manifest centric example here. I want to go from 1 replica to 2. Right. So if that makes sense, right, whatever the approval process is, for example, if you're using GitLab or GitHub, if you're doing a merge request or a pull request, once those things are approved and they're back into the SCM, those changes are automatically applied. And then you'll notice that if you're using a sort of GitOps system, right, as soon as a PR kind of hits, and if you're looking out for a main branch or some other branch, you're doing kind of trunk-based development, the agent will kind of go and try to apply those automatically, saying, okay, like the change is needed. And kind of going to that, since there's agents applying the changes, agents, that fourth pillar there is agents can also ensure correctness. And what this means is that reconciliation or drift detection, saying that, hey, you know what, in my canonical state, I'm saying that I want only 1 replica. That's in our main branch in Git. Versus someone goes, kubectl, like modify, like patches the manifest, or like uploads another manifest outside of source control. say I want 2 now or 3, like that wasn't in our canonical state. For example, a reconciler can go through and say, hey, like, you know what, the desired state was 1, someone went and patched it to 3. Let's go ahead and reapply that to 1. So there's really kind of like the four main pillars of GitOps systems that we have today. And so what do we mean enterprise grade? Okay, so we know what CICD is, and we kind of understand like, okay, like GitOps means these like 4 pillars. But how does this kind of tune into us into the enterprise, right? And so one of the things really meaning enterprise grade is that the biggest thing versus if we're doing something locally versus like, oh, our like job or people depend on it, it all boils down to confidence, right? Like, are you confident that what's been written and what's being deployed actually does the feature match the expectations? So going from code to production requires a lot of confidence building exercises. You know, what is a confidence building exercise, you might ask? Well, that can be a test, right? So it could be a unit test, functional test. There's a whole bunch of tests out there. It can be, you know, if you're prescribed to, the SRE model, there can be a SOAP test, a perf test, chaos engineering, a chaos test. There's like always like these confidence building exercises are always new paradigms are always coming about. But basically, it's how do we make sure subjectively and objectively that what we've written or what we want to deploy, it's meeting the expectation, right? Kind of the second part is being enterprise grade. Kind of with a pure GitOps approach, they really rely on everything being declarative. That was like actually pillar number 1. If we kind of go back to the previous slide, like the entire system is described declaratively, right? But there's certain tasks that are just not declarative, right? Like even though there's been lots of advancements in infrastructure as code or IAC, for example, if you're familiar with like Crossplane as a project, right? Like the Kubernetes-based IAC, there's still a good amount of infra that is not declarative. Like, if you had to spin up certain cloud resources, or there's certain things that require a specific order of operations. So it actually needs imperative commands. Like I need to do A, B, and C in that order. I can't do A, D, and then C, like something would break. We need to be more imperative when order of operations versus declarative. We just declare in the end state. Those things are always common in the enterprise, right? So it's a good old, the round hole in the square peg problem. These are items that how do you kind of massage this into a GitOps paradigm? And that's what we're going to be talking about today. So GitOps architecture. So Nick, I want to take it away from what is always present when doing GitOps.
Yeah, so let's kind of get down to fundamentals for a moment, and I think this is really important because we can get lost in like tool chains, but ultimately from an engineering practice, it's helpful to simplify. Like, what are the fundamentals that are always present when doing GitOps? And here I'm going to kind of use GitOps as a verb. And if you again think about the term, it's a joining of 2 words, Git and ops. So at minimum, the 2 things you need is you need Git version control and you need operations, which we're calling just deployment on this mermaid diagram. So the declarative aspect really comes in version control and your configurations that you are version controlling. So whether it's Kubernetes manifests or Terraform modules, whatever it is, we're trying to ensure that we're describing what we want. And within the version control itself, we're not necessarily explaining how the deployment happens. So we say we want resources A, B, C, D, and so on. And we want these resources configured a certain way to ultimately be present. And we declare that as code in our Git repository. And then the second item is our actual like deployment infrastructure. We need to make sure that wherever we're deploying to can support the resources that we're declaring in version control. So it's for that reason that very often GitOps is combined with cloud native type deployments. That is, we don't want our infrastructure to be, say, resource limited, because now we have an external constraint that we're trying to, that would then be imposed on what we're trying to declare in version control. Well, we don't want that, right? We want everything we need to be encapsulated in that Git repository. So when it comes to things like auto scaling, for example, or bursts of demand for resources, we want that to not be a constraint from whatever it is we're actually configuring. So from the deployment aspect, a typical infrastructure for that is some kind of operational environment that is heavily automated and supports our declarative configuration. So a classic example is Kubernetes. It doesn't strictly have to be Kubernetes, but Kubernetes is designed from the beginning to be A, declarative, B, very scalable. And then you see those kind of two vocabulary words at the bottom. I'll describe those in a minute: immutability and idempotency. Those are core parts of Kubernetes as a container orchestration system as well. And then, so really, version control, deployment, which we might consider to be the ops piece, like those are the two core definitionally correct, description of GitOps. What we might add as well is observability. We might, if we want to be super technical about it, we might make the observability piece more of kind of a dotted line. It's certainly like necessary to have, but it might be handled in different ways. And the reason it's really included there is because how do we bridge? How do we get from our version control configuration to deployment? Well, we normally use software tools for that. And Ravi will talk more about those typical tools in the next slide. But ultimately, like what we need under the hood is one way to detect, reconcile, and log how we're getting from version control to our production infrastructure. So not only the how, like how are we taking these resource configurations and making them live in prod, but also how do we handle deviations like drift or out of syncness with our prod application? How do we handle the need to scale? How do we audit what we're doing? And that's where the observability pieces come in. And oftentimes, like that's not like inherent to GitOps. It often requires a separate stack or separate tools, but at the same time, it's crucial. Now let's look at those words at the bottom of this slide: immutability and idempotency. Those are two words that are also core. They're fundamental to GitOps. They need to be there. So the first one, immutability, is really inherent to Git. So immutability simply means once it's created, you can't modify it. Once there's a chain in the commit history, you're not supposed to like in place modify that commit. Rather, you make a new commit. Anyone who's experienced like Git revert before knows this, right? When you revert a commit, when you do a rollback, you're not literally modifying an existing commit, you're creating a new one that applies a previous change. What this means in practice from an infrastructure perspective, from a deployment perspective, is that we're treating, to use the DevOps analogy, we're treating our resources as cattle and not pets, right? We're not taking our resource to the doctor to try to get it patched up if something's wrong. Rather we replace it. And again, the goal there is to ensure standardized deliveries, so we don't have duct tape and glue all over our infrastructure, trying to fix things that really should be built and replaced from the ground up. The second kind of I word there on the right is idempotency, and that simply means our declarative configurations, when applied, they need to be predictable. So it means that if you have a configuration and you apply it, it should result in the same output every time. If configuration A produces resources 1, 2, and 3, that should be the case every time. And what that means is that if you already have resources 1, 2, and 3, when you reapply configuration A, that means nothing should change, right? So when you reapply a configuration and you already have that result, it simply means that you maintain that same result, but you're not suddenly making changes. So a little bit of other concepts that go into that is the concept of like deduplication when it comes to some sorts of configuration management and templatizing, but it simply means that it works the same way every time. Now, I'll add one last thing before moving on. So many tools over the past 15 years have like gone this direction to enforce immutability and idempotency. One complication that we'll start probably seeing in the next year or so, if we're not already seeing it now, is the increased use of generative AI when it comes to configuration, creation, and enforcement, and figuring out how to create different deployments, is because generative AI is non-deterministic. When you enter an input into a Gen AI prompt, you don't know exactly what output you should get. It's non-deterministic. It's not going to be idempotent necessarily if you have that as kind of a middleman in the midst of these GitOps processes. So I just kind of wanted to mention that as well. All right.
Cool. So I wanted to talk about kind of like also like, okay, so standard tooling that's out there. So we kind of got some of the theoretical stuff out of the way, but if you really just Google like GitOps today, like, you would kind of see two main kind of projects out there. You would see the Argo project and you would see Flux as a project, right? So those, the kind of the two most kind of popular things from Argo is like actually ArgoCD. So if Argo is the project, ArgoCD is like a sub project, a part of like the overall project. And same thing with Flux. Flux CD is part of like Flagler, Flux. Like there's a whole bunch of sub projects in the Flux ecosystem. But basically these two particular tools or two particular projects, I kind of try to assume the same thing. They try to enable the 4 pillars of GitOps, right? Like they're able to apply, the manifest. They're able to reconcile the state between what's in source control and what's in the end state system. Let that be Kubernetes, right? They do approach it a little bit differently how they're installed, but these are like the standard tools. If you were to Google it, today, Argo and Flux would be there. Paying homage to tools of days gone by, like Jenkins X, right? That's been out there, or Tecton, right? Like those other tools are out there, but these are two of the most popular tools out there for GitOps implementations. And so let's talk about things that, okay, regardless of like GitOps implementation, what do these tools do not handle, right, by themselves? What they don't handle. So the first one would be workflows, or things that need to be that are persistent, or things that are decisions. Now, these particular pieces of toolings are, they have the ability to apply and manifest. Now, there are sub projects out there that try to implement a little bit of workflow control in the Kubernetes, but this is more of a take on like Kubernetes itself. Kubernetes is actually very bad at like long running tasks or jobs, right? Like it's basically you give a manifest, the reconciler, the scheduler, the resource management portion of Kubernetes will try and say, hey, you know what? I need 2 replicas. You drop the hammer when you say kubectl apply f, right, in the manifest. To the best of the scheduler's ability, it will try to place the work and meet that desired state that you said. So like having a workflow, like, oh, you know what, we need to have a decision tree, or like, hey, you know what, if this happens, do this, if that happens, do this. You should get into more imperative commands, which a declarative system is like not very good at, and making decisions like, oh, we have to get an approval. Like, in an enterprise, like a lot of times you have to get approval to do anything. In the office side, I'm actually Nick's manager, right? But sometimes Nick needs approval for stuff. Sometimes I need to go to my manager, to get approval for things. This is how enterprise works, right? Kind of boiling into that second piece there. Like, if you have non-declarative infrastructure or things that are imperative in tasks, it's hard. Like I've used Crossplane before and I had to get A, B, C, D kind of lined up, but how Kubernetes works is that, it's a retry scenario. Like, hey, if you need to have A, B, C, D happen in that order, let's go ahead and if D starts before A, we'll assume that D will continue to fail until A and B. I'll make it easier. If B needs to start before A, but a declaratively would fail before A would start. So with that, if you look at how these resources are spun up, you'll see a lot of like retries or backoffs, right? That'll happen saying, okay, like playing slot machine, 777, cherry, you might get 7, 8 orange, right, until all the bars line up. That's exactly what is happening. If your systems cannot handle that gracefully, it's not a good GitOps model, right? And also going into like that, not handling something gracefully, failures and regressions, right? Like the Kubernetes way of handling a failure is to retry, right? Oh, keep this retrying. You know what? This resource didn't come up. Just keep going until the scheduler is exhausted, or which it doesn't. It's a system. It'll, wouldn't be exhausted like humans, like we are, right? But it's something it doesn't handle very gracefully are failures. Like, hey, as an experienced engineer, like if I compare my when I started out being an engineer to now, I used to start with the vanilla happy path. I was like, oh, it'll always work. Like these three, this will always work. The older I've gotten, I've actually, if I get it to work the first time, it actually is not working. Like never got something right the first time. And so actually designing for failure, it's like, hey, when we go to build something, we need to design for failure on the onset. And so that's, failures, regressions, like, hey, other than retry, is there another, you need to roll back? Do you need to like stop? Do you need to take a breather? Like what do you need to do in this failure scenario? GitOps is always drop the hammer, keep retrying. Not very good at that. So enterprise system design. Let's talk about kind of like the 4 pieces of enterprise system design. Nick, I think were you taking this piece or was I taking enterprise? I'll take this piece. This is mine. Sorry. So we're trying to share like one set of slides here for the sharing program here. So requirements in any enterprise, right? And so I'll start with robustness, right? Then I'll get the building compliance and confidence. And so, like anything, robustness means that there's a general expectation that the resources or application or service is there when you need it. Like it's kind of like, hey, when your customers need it, your internal users need it, internal, external customers need it. And so like, how do you actually go about accomplishing that, right? Like if you look at system design, like, for us to be robust, we need to deploy to more than one spot. We have more than one cluster, we have more than one pod. we have more than one availability zone. There's cluster and replication stuff going on. So like mainly there's more than one, right? Like you have to kind of have another like instance of something running. Also, we talked about this earlier on, like confidence, like testing, approvals, like does the feature match expectations is very important. And same thing, like if you're just looking at like a manifest, like if you're deploying like an application, at some point, like you need to deploy the app, right? And so like if you look at very specific like GitOps implementations, it's only focusing on the deployment. Like what about, you need to build a binary, right? Like if you're writing a Go app or a Java app or a Python app or Rust, like all these have binary distribution formats. Like where's the build, right? Like you just, at some point you might be pulling from a registry, but how does the application get into the registry? It's another one. And then compliance, right? So depending on how regulated your environment is, or depending on like the customer base you deal with, or like the type of institution you're in, just having compliance, right? It's a wide paintbrush of a word, but hey, you know what? Even there's business controls that you have to, like going back to confidence building, like certain things, like you need an approval, you need to show an audit trail, you need to show XYZ. Some of those things might be in source control. I actually bring that up later, like get blame, is a good audit trail, but sometimes it's not enough to get us through the line. And let's talk about real world architectures now, Nick.
Yeah, can you advance one for that first animation? So remember that mermaid diagram I showed a few slides ago, and I said GitOps has a few fundamental capabilities. So we have those highlighted in green, and then we've extended it, which I'll get to in a minute. But so version control, deployment, kind of the dotted line around observability. Well, think about how you actually like have your enterprise software management process in real life. You really have more than that. So can you advance to the next one? So you need some way to automate things in general, right? That's where DevOps comes in. And this will be the example that I'll do a little bit in a demo. Is real life is not all declarative. Like there are sequence of steps you have to follow. That's how like laws and regulations are written. Sometimes they're outcome based, but other times like your organization's chief counsel has to sign on the dotted line once a certain piece of paper or document comes in front of him or her. Like we can't automate that process away. When it comes to compliance and approval steps, we might need to verify through a sequence of steps, whether something is compliant in terms of code, in terms of like cryptographic integrity, in terms of being free from security vulnerabilities. That's why like manual QA like doesn't fully go away. If you're building an airplane, you have a set of regulated steps you need to follow. When you automate those steps, or when you attempt to, you're introducing an imperative process. You're trying to make those steps go by faster or have them standardized in the form of a pipeline, but you're not fully reliant on an automated tool to just decide for itself how to reconcile a declarative source of truth with your infrastructure. So CICD pipelines as imperative workflows going from steps A, B, C, D, E, F, and so on are going to play a role. In addition, and can you go to the next? In addition, you also have all the human organization, what we might call bureaucracy, that's just an inevitable part as well. Like who is responsible, right? Where does the buck stop in terms of people when it comes to who is approving, for example, a release, right? When someone makes a new commit to the main branch of a Git repository, you might rely on tools like Argo and Flux to actually do the deployment, but who's ultimately responsible? And who should even have access? If there's a situation where you do need to maybe break the GitOps paradigm and jump in and make like a change to a live environment, how do you manage that process? How do you enforce the regulations and steps that might be accomplished in CICD? That's where policy management comes in. Who blesses the security tools that you use? Who determines whether or not, do we halt a deployment based off a vulnerability of severity level medium versus high or critical? So the reality is that the slide might look a little bit like involved, but really all the things that are circled in yellow are not inherent parts of GitOps, right? They're things you need to integrate GitOps with, but bringing in your GitOps, Argo or Flux tool of choice, that accomplishes the narrow band of take what I have in Git and make it appear in production. But there's all the real world management and compliance enforcement that needs to happen around the edges as well. So if you go one more advancement, I talked about, yeah, GitOps is immutable. It's idempotent. It's all these like ideals of having, you know, a perfect release cycle. But in reality, the real world is messy. Nothing's ever truly a closed system. You always have interventions here and there in order to ensure that your company is, you know, not, you know, your company, at least for liability reasons, or even just performance reasons, is ensuring that your releases are what they're supposed to be. So in reality, real enterprise GitOps is not just these ideals, but it also includes CICD and end-to-end monitoring and policy enforcement, and then whatever security stack has gone through like all the layers of being blessed by different levels in your organization as well. So really what this is saying is that like GitOps requires some reconciliation. It's really easy to, you know, create a demo of an ideal, but that's not how, you know, organizations of any meaningful size are able to truly practice. You're always bringing in your existing cruft, we might call it, and having to integrate it with the new fancy models of deployments.
Let's talk about kind of common challenges, right? So like if you take a look at like what are these things that we're circling, and like why are there actually a challenge, right? And so kind of the first thing is like, okay, like if you're embracing like the GitOps model, like you hope to have configuration drift, right? Saying that, what does this mean? Going back to our very first like, you know, kind of like pillars of GitOps is that, hey, you know what, declared state was in source control was like one pod, one replica. You know, on the system it's 3 for some odd reason now. How do we that's drift, right? Like what was intended and what has been decided upon versus what actually is occurring in the system. But with drift, it becomes a problem that if things are like non-declarative, like you have imperative commands, right? So for example, like if you're using Terraform as your IAC, right? Like how do you go about figuring out like configuration drift on Terraform? Now, what you can do, right, you can just kind of like reapply, you know, TF apply again. Like, yeah, this is what I needed. Just delete and reapply. You know, like there's the ability to recreate at any point, you know, is the system design principle, right? But like if the drift is very small, then it's like, well, we take hours to recreate all our infrastructure just to find like a small stack. That's one challenge, right? The other would be just the platform itself. You know, it's like the Kubernetes, the Genesis Kubernetes argument. Like, how do you IAC out, you know, Kubernetes itself? Like, do you use a Kubernetes IAC, like crossplane, to spin up Kubernetes resources, like more clusters, right? Or do you use something like, if you're using like EKS, like you use a CloudFormation or Terraform to spin up, you know, if you're on AWS, like your clusters, right? So, like, there's areas that GitOps like wouldn't be able to touch, and then also like just alluded to, like items that are not core to Kubernetes, like cluster management. Like if you have a cloud service or a database or RDS or something like that, or SQS, like when you have a non K8 based things, like how do you look for drift, right? This is one thing just to keep in mind of. Also, security and compliance. This is a good one, right? So, like confidence building always changes, right? And so this is actually going to kind of play into like the next slide, but I'll kind of try to combine these two and get to the demo a little bit quicker. So, when dealing with confidence building, right? Like there's always an additional type of confidence building. Like a big one right now, like, you know, if chaos engineering was like really popular a couple of years ago as it's more cutting edge testing, security testing is becoming a lot more popular. If you're familiar with like software supply chain, so like SBOM, or if you're familiar with like SSLA, like SALSA, always, you know, add an A in there, SALSA, the standard, and these things are becoming quite critical in software delivery now. Like, hey, how are we like, you know, ensuring the security of our supply chain with a bunch of open source? You know, with these particular scanners are very workflow centric, right? Like they're imperative. It's not like, you know, if you have a manifest, I'll go to the next slide now. Like a black box. Like I don't have a manifest saying SSCA, you know, or like software supply chain good equals good, right? In a one line of a Kubernetes manifest. That is a company idea, though. Now that I'm thinking about it, like, hey, like that's a very declarative way of saying, oh, do we have supply chain security? But it might be like, hey, there's things we have to prove. You know, we have to prove custody, we have to prove digital ownership, we have to prove lots of things, and those are imperative things. Those are workflows, right? Those come from scanners. Those come from understanding digest and registries, and you know, there's a lot of decisions that go on there. And so, where you know, kind of some of the pure GitOps, like immediately be declarative implement goes on where it kind of which struggles is exactly that, right? Like, hey, you know what? Some of these particular toolings might be a black box. You know, you just need to you submit something, get an answer back. still there's like that's imperative in the overall workflow because you need to call the tool a certain way, and such. And so with that, let's go ahead and show people kind of enterprise GitOps, any enterprise GitOps in action. Give folks a second. I believe this link will take you to a tutorial written, but Nick, take it away.
Yeah, I'm gonna give folks just a minute to capture that QR code. So really, where that QR code takes you is a documentation page that's effectively like the steps of what I'm about to show. So if you ever want to kind of repeat my example on your own, you're more than welcome to do so. I'm going to show you kind of nearest to the end result. Like I'm going to show you kind of the complete package and then what the actual pipeline might look like. But let me go ahead and share my screen here. Let's see. Okay. So, and give me a minute. I'm going to zoom in. It might look kind of zoomed out at first. I'll check the chat.
It looks good. It looks
good. Okay. So this is a Git repository. And here's where I'm going with this. This Git repository contains code. It also contains deployment manifests. I am trying to approach the ideal GitOps model of having everything, both code and infrastructure operational pieces, stored in Git. So this is the version control part of GitOps. So this is like one example of a deployment manifests. If you're not super familiar with like Kubernetes and like the YAML format they use in configurations, don't worry about it. I'll kind of show you the visual of what's ultimately deployed here. But ultimately what this is doing is like we're deploying things to infrastructure. And that thing is an application that I built that is deployed as a microservice. Here we have some networking. We have all these different like aspects that I'm trying to configure. What it actually then looks like is we might have tools under the hood like Argo or, sorry, give me 1 minute here, Argo or Flux that ends up actually like doing and handling the deployment itself. So if I go ahead and go to here, you should be seeing this harness screen now. Let me know if you don't see it. This shows a like actual deployment. And if you ever use tools like Argo, this is a very similar view that you see. This is just in the harness platform. So we have our application that then gets deployed to a couple of environments that we might call dev and prod. And then if I actually go under the hood to each of these environments, these are the actual like Kubernetes resources that were actually declared in my manifest, right? We have a service, we have a deployment, we have replica sets, we have an underlying pod that's actually like the endpoint that users would access. So far, at least, we have like this pure GitOps model of seeing a YAML configuration and then tools that are doing work under the hood actually make that configuration live in some environment. But remember when we talked about like there's all these other aspects that come into play as well. We need to like make sure that our code is like free of vulnerabilities and that maybe there's like approvals required. Like maybe we can't just deploy to a staging environment or a dev environment and a prod environment. Like let's go back to this view here. Maybe we need to like make sure that we have gating in between our deployments. Like, yeah, sure, we might be able to deploy to dev or staging, but when it comes to production, like we need to have constraints over that. And that's where we need to implement that pipeline piece. It's that imperative aspect that layers over our declarative GitOps. Like, how do we ensure that we're following all our internal regulations as well? So with the harness platform, we're able to combine them both together. We can have a pipeline that preserves our declarative nature when introducing those imperative steps. Now, what do I mean by that? Well, let me show you. I'm going to go to this pipelines view, and I'm going to show you kind of this execution. And this is a full end-to-end CICD pipeline. Remember our definitions from earlier, we have CI, which is build and test. And if I look at the CI stage, we have that here. We have, we clone our code base from GitHub in this case. We might run some tests. We kind of have an OWASP scan. That's our kind of placeholder for all these tests we want to run. And then our actual build is we build and push to some artifact repository. In this case, it might be like Docker Hub or some cloud-based container registry, or it might even be local. And that's the CI aspect. And then if I look back at the top here, we have 2 additional stages with an approval step in the middle, right? Again, the pure GitOps paradigm like doesn't accomplish this. GitOps just says, take what's in code and like make it live in an environment. It doesn't have the gating that's required by a pipeline. We're actually kind of deliberately, honestly slowing things down a little bit and saying, hey, we have this deploy dev stage, and this only does the deployment to our dev environment. Now, how does it do that? Remember I said that GitOps tools normally do this automatically. Well, the idea here is preserving our GitOps cycle. Let me minimize that here. What it's ultimately doing is it's performing a deployment, and then any environment variables that need to be updated, it's actually doing a Git PR merge to do it. So let's think about that for a moment. So we have our like clusters that are our actual infrastructure. But if we're actually making a meaningful change, that is, if we're not making a change, nothing would happen. That's idempotency. But if we're actually making some kind of like meaningful code change that would cause our environment to update, the platform itself will perform the necessary like compliant Git branching steps to do it. So this is not me opening a PR manually, making a commit change, and then hitting merge. This is Harness opening a PR, changing whatever variables might be needed, and then merging that PR. And then the application is synced. That's then the live state is synced to update whatever's in version control. In fact, if I actually look back at my Git repository here, and I go back to like the front page, it says the last commit, which I made about an hour ago, was a pull request merge, and it says it's from like Nicholas Lotz, which is me, but I didn't actually do this. What I did is I ran a pipeline, and Harness did the Git compliant workflow of, okay, everything needs to be stored in Git, rather than just doing like, you know, a go ahead and update like the environment manually. I'm going to actually make a change to the Git repository, and then our GitOps tool will perform that update. So that's the dev environment, and that updates dev. But at the same time, we might want to like pause after that and say, okay, we need to make sure that everything's still working as expected. For like web applications and things that aren't mission critical, we might be okay like also doing the update to prod, and then just, you know, stepping back and saying, okay, if something breaks, we'll just do a rollback. That's not okay if you're using any kind of mission critical systems. If you're building airplanes or creating medical devices, it's important that you can verify things are working before, you know, let them loose on people. So we might have this approval step that literally is a checkbox. So when this pipeline runs, this pipeline completed, but literally when this pipeline runs, CI happens, deploy to dev happens, and then the pipeline stops. And someone literally has to click I approve with maybe optionally a reason why before the pipeline is allowed to proceed. And then finally, the deploy to prod happens. And this is meant to be identical to deploy to dev, except it's to a prod environment or a prod cluster instead of a dev cluster. Now, this whole pipeline is triggered from a commit to a repo. So a git commit is what makes this happen. So we're not going to just kind of sit tight and see the whole thing run, but I do want to show you that the triggering of this pipeline will happen because, you know, maybe someone makes a change. So if I just like change this README, for example, and I might say, you know, add new important docs, and I make a new commit, it doesn't really matter where. In fact, I don't think I actually turned my screen over. So in the background, I just made a short commit to that Git repo, just in the README file. We now see that there's a new execution taking place. I didn't hit run pipeline. This was triggered because, again, we're trying to preserve that dev style GitOps integrity of all deployments happening through changes to a Git repository. And this pipeline takes a few minutes to run, but we can see that it's starting at the CI stage. It'll proceed through the initial deployment to dev, and then it will stop. It'll stop until we approve, and then it'll proceed forward again. So again, really the goal of this is to show this reconciliation of we have an imperative pipeline. Like this is imperative. It is performing steps in the order that we tell it to, exactly what we say, but it's also preserving the write back to a Git repo to ensure that like everything is auditable and any change that we make is through this Git commit chain on a branch. So that's that end-to-end process that kind of brings together what we would consider an enterprise-grade experience. And I'll add one more thing. This is happening on the Harness platform, which means under the hood, we have all sorts of like role-based access control that you can create as well to ensure that, you know, only certain people have access to certain inputs or pipelines, right? That there's an object-based way of ensuring access as well to all these things.
Could you just hit console mode real quick? Someone asked just what it looked like.
Yeah.
Just on the top, right? Yeah, just a
console view. Yeah, so this is just showing. Yeah, so this is just showing like literally the terminal output. So right now we're running Docker build, and it's showing what it's doing under the hood. Now let me be clear. This is running on infrastructure that I just have like in the cloud. I just have a Kubernetes cluster that I've connected to Harness, and it's running. It just finished the initial, you know, build and publish step, and now we can see here that it's deploying initially to the dev environment, and then this should be done here in just a moment. So yeah, you can look at all kind of the terminal output as well. All right. Well, and what I might do is I might wait just one more minute for this to finish, this initial step, and we can also see the gating as well. So we can see the deploy to dev finished, and are now on this approval. And we can see the pipeline's just spinning. It's not actually proceeding. Like we need to approve or reject. So if I click approve or reject, you know, I might give a comment as to why. I could even enforce that if I really need to, or I might just say it looks good to me. Again, this might be someone with authority to approve it before we're allowing to deploy to prod. And then we do so. All right. So I had my kind of screen taking up most of my real estate here. Not sure if any question I didn't immediately address.
Yeah, I was answering a few of them. I think we can just go, we can finish, and then we can just kind of open it up for Q&A
Cool.
At the end. We're almost over. So let me just share one more little bit, and then we're good to go for Q&A. Yep. Bright marker and me. Let's see. Share screen, not share presentation. And let's see. There we go. All right. Let's just kind of move this forward. Again, just like lastly, like, you know, since we do work at Harness, you know, like what we showed you was Harness. And hey, no matter where you are in the journey, like Harness is a very modular based approach, right? So imagine Harness as, you know, a software delivery or DevOps platform. And what we kind of showed today was our two modules: our build module, which is CI, and our deployment module, which is CD. Especially the GitOps capability of our continuous delivery module. But regardless of like where you are on a software journey, what we brought up is like, hey, what if you had additional ways to test security? Or what if, you know, you wanted to become more efficient in your software delivery, or cloud cost was an issue? We have lots of capabilities at Harness. You know, we always happy to kind of get in contact with us. You know, go to Harness.io. You can join our community Slack. Nick and I are on there. Feel free to reach out. Happy to chat with folks. And yeah, I just want to thank you, Nick. Thank you so much for an excellent presentation. You know, thanks for the folks asking questions. And I think we have like maybe 2 or 3 minutes for questions. And so let's just mind if I just read them off. Let's see from the bottom. Will Ada have the capability to build CIA and CD and GitOps pipelines from a prompt? It's getting there. You know, Ada can kind of write like OPA policies and whatnot. It's getting stronger every day. So I would say if it's not there today, it wouldn't be too far off. Can we get specific stages from your example on the GitHub account? Yeah, the config as code or pipeline as code is available in the example. If there's anything else, you know, we're happy to.
Yeah, let me address just a couple of these. So actually, so the stages, the pipeline stages themselves are using and deploying from the manifest in GitHub, and that's a little bit of those like, you know, kind of imperative plus declarative aspects. So like in that GitHub repo, I do have like a reference directory that includes like the manifests I use. So we might have the manifest themselves, or the stages themselves synced back to a GitHub configuration. But what's most important is that they are using and providing guardrails around the manifest we're actually deploying. So I didn't show this. There's actually a tab in Harness where it showed like the visual UI icons of the stages, but I didn't hit it. I could have hit the button that says YAML, and it shows like the YAML view of all these things as well. And that's like the as code aspect. And then, sorry, I'm going to grab this question here at the bottom as well. How do you compare Harness to GitLab? Yeah, so actually, I have quite a lot of experience with GitLab in my past, and honestly, from deployment perspectives, there's two big advantages that I would say Harness has. Advantage number one is that the deployment management is simply more advanced. So the support Harness has for like these PR pipelines and incremental rollouts and canary releases and advanced kind of plug and play, dynamic testing strategies is not easy to implement in GitLab, and it's not obvious. In addition, GitLab really like enforces pipelines at like the individual repo or project level. In GitLab, everything stems from having like everything in a single repository. And then you could always bridge connections with multi-project pipelines, but Harness has a lot more modularity where you can create one pipeline that might draw from multiple repos and that sort of thing as well. And I'd also say that the last aspect is with GitLab, you have to start by knowing how to write everything in YAML. Like, you don't have the UI builder that Harness has, whereas Harness, you can start off mocking things up in the UI and it generates the YAML for you. GitLab, you kind of have to know the language from the front end and then hope that you can kind of build it from scratch. So those are a few things I've seen, working with both tools.
Yeah, great explanation, great encapsulation. Yeah, don't take our word for it. Try it yourself. Like sign up for free SaaS and.
So I'm going to jump in one more time because this is another really good question. Is Harness open source? Yeah. So two answers to that question. Number one is like I was using the Harness SaaS version, and that does have a free tier. It doesn't have an open source license, but it does have a free tier that you can try out if you go to app.harness.io and sign up. Also, we have a tool called Gitness that I'll just like type in chat here. And Gitness is kind of our like underlying open source offering that you can like self-host in a Docker container that is intended to like integrate with Harness SaaS, where you can try out a lot of the same types of things that I was doing when it comes to builds and that kind of stuff. Harness supports from build all the way through deploy. So it's meant to have items for both, build and test, CI, and then the advanced kind of CD and deployment capabilities, which tend to happen after build as well.
Cool. Yeah, it looks like we're right at time. Give it back to Cody for the wrap up. Thanks, Nick.
All right. Well, Nick and Robbie, thank you both so much for taking us through the fundamentals, building everything up, and then showing us how everything works. I know a lot of time goes into making sure that your demos are successful. So thank you both so much for the time that you've put into this and for spending time with us today on TechStrong Learning.
Thanks for having us.
Of course. So before I release our audience, a couple of closing reminders. Our session today was recorded, and we'll be sending you this recording as soon as it becomes available. But you'll also find it living on the DevOps website. Just visit devops.com/webinars, and it will be in the on-demand section. Another call out for, I'd like to thank everyone for their participation today, for your questions and for your chats. So submitting any of those did qualify you for our $50 Amazon gift card giveaway. However, if you'd still like to become eligible, there is a link to our survey, both in the handouts and at the top of the chat. We would love to hear your feedback about our program. I'd like to thank Harness for sponsoring our program today. And to everyone, thank you so much for being here. We appreciate the time that you take out of your busy schedules to spend with us here at TechStrong, and we hope to see you at a future learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, guys.